Hi everyone. Now, as I mentioned in class, we're going to be going over the 2018 exam in these videos, and we're going to do this over 3 different videos. The first one's just going to be the calculator free section, and in the second and third videos, I'll take care of the calculator allowed section. I'm doing it in 3 videos so I can give myself a bit of a break, basically. Now, as we go through this, you'll also need to basically make sure you know what to find on the formula sheet. Now, we've got all the stuff from the formula sheet, and I'll be pointing out the stuff that's important on this formula sheet as I go through where it's relevant to do so. Okay, so let's get going. Now, let's have a look here. First question, it's pretty straightforward. We're solving a linear equation. We're solving that for t. So what we've got to do is expand. We get 5 times 2t is 10t. 5 times 1 is 5. Negative 3 times t is take 3t or negative 3t. And bear in mind here we've got 2 negatives, so that would end up being plus 12. 10t take 3t is 7t. 5, remember this is all equal to 0. 5 plus 12 is 17. We rearrange, so we get t on its own, and then we get t equals negative 17 over 7. Now, sometimes you will get fractions as your answers, and this is just pretty straightforward. Even if you think you're probably doing the wrong thing, it's still good to follow through. I know that negative 17 over 7 isn't exactly a very common number, but in this instance, because the maths is fairly straightforward to rearranging all this, it's just about being confident with your answers, even when they do have a fraction and negatives in there. So let's have a look at this one. This one's a little bit tougher because we've got to do some rearranging. Now, when we have a fraction, or when we've got fractions like this, it's always good to rearrange this so that we've got a take 5 on one side, and this is a negative here, so I'm going to put 3 over 4a on the other side. What we can do now is we can actually cross multiply, remembering that this is effectively in brackets, so I'm just basically multiplying both sides by 4a and both sides by a minus 5, which ends up giving me 4a times 7 equals 3 brackets a minus 5. Let's expand that. That's 28a equals 3a minus 15. I subtract 3a off both sides. That gives me 25a equals negative 15. So I get a is negative 15 over 25. And we would like to simplify that to negative 3/5 because they've both got a common factor of 5 there. So that's that one there. Not too hard to solve, just so long as we're methodical and careful about it. And negative 3/5 is a perfectly reasonable answer for what we'd expect to get there. Remember that this one's worth 3 marks. If you make a mistake somewhere along the line, it is still possible to get part marks, so long as you're being logical about what you're doing. Okay, solving these equations, we had linear equations above. This is a quadratic equation. And when we solve a quadratic equation, we always want to rearrange it so we've got equals to 0 on the other side. So we're going to do 6x squared take 3x equals 0. We want to factorize this. Both sides are multiples of 3x, or in fact, we can just think of them as multiples of x. So if I take x out, I've got 6x take 3 equals 0. So I want to find where either this part is equal to 0 or this part is equal to 0. If that front part's equal to 0, it's just got x equals 0. That's an obvious solution. And we can put it back in here and it makes sense. 6 times 0 squared equals 3 times 0. And the other side here, the only thing that makes sense is x equals a half. And again, if I that would be 6x equals 3 if we rearrange that so that it was equal to 0. So x equals a half in this case, and we should be able to calculate that out. If we really wanted to, we could put it in here and calculate it out again. So that's our answer for those. not too hard to do. This one is a little bit more complicated. First we want to expand it, x squared plus 2x. And we want to do subtract 24 equals 0, because we always want to arrange it so that we've got all of our terms on one side and we've got equals 0 on the other. So now we may have a bit of a think, how can we factorize this so that we got two numbers that multiply to 24 or negative 24 and they've got a difference of 2 between them. And this actually ends up being 6 and 4. So one of them's going to be negative and it's the smaller one that's negative. I know that the smaller one is negative because our result over here ends up being positive. So 6 times 4, oops, that should be x minus 4. So 6 times 4 is 24, there's a negative in there, it becomes negative 24. X times 6 is 6x. Take 4x gives us 2x as we need, and then x squared is the x. There's just x squared as our squared term there. So x would need to be negative 6 or 4 for this to work out. And that's our answer there, pretty straightforward. We could have also used the quadratic formula if you got yourself completely stuck, and it's totally fine to get completely stuck, but in here we've got the quadratic formula in here. We can use the quadratic formula at any time if we just want to throw the numbers in there and work out what the answers for x should be. That will give us the answers for x directly instead of having to use the zero factor law to work out what they were over this side. But being able to do that does sort of get us out. And it's 3 marks. We've technically got a few minutes to work out this one. If you get completely stuck, you can always just use the quadratic formula to math it out. Okay. Next up, a function is defined by f of x equals square root 3x. Calculate f of 12. That just means throw 12 in where x is. That's going to be square root of 3 times 12. That is the square root of 36, which we should all identify as being 6. What's the domain and range of f of x? This is going to be a function, a square root function that looks a little bit like this. Now x can take any value that is greater than 0. It can also be equal to 0. And likewise for y can take any value that is greater or equal to 0 there. So the domain and range of x, we want to write that out. Domain is always the x value. X is greater than or equal to 0. Or if you want to write it formally you can write x is a member of R such that x is greater than or equal to 0. That's the completely formal way to write it, but I would give full marks for that one anyway. And range is our y one, or we wouldn't really use y, we should technically use f of x because y hasn't been mentioned here. F of x is greater than or equal to 0, or you would write it formally as f of x is a member of R of the set of real numbers such that f of x, let's neaten that up a little bit, such that f of x is greater than or equal to 0 as well. Now you would get full marks for writing it like this as well, but it's just important. Well, one of the most important things is just make sure that you're talking about domain and range correctly. Domain is the x value. They will always say domain first and then range. They won't say state the range and domain. They'll say it this way around. Just to remind you that we do x first, then y, or f of x rather. So that's that one there. Now we want to sketch the graph. I've already sort of sketched it here, but we've got some points. When this is 12, when x is 12, when x is 12, f of x is 6. So let's put that here. This is a known point. So that's going to be one of our points. We have another point down here. When 0, we've got 0, it's 0 on both sides. We want to have a look at this and think, well, what are our other known points in our square root of 3x? Let's just write that here. So that is the square root of 3x. What's another known point we can get? So if x is 3, 3 times 3 is 9, square root of 3 is, or square root of 9 is 3, so that's going to be another point. So it makes sense to have these, and we can sort of draw that. Now the actual accuracy of the line is not completely important, but it is important to have a few key points identified like we've got there. That's where we're going to get our 3 marks, by identifying points, having a relatively smooth line, and just drawing it accurately. And if it conforms to everything else in here, then that's great. Okay, so that's that one. So now we have a line. What's the equation of this line? Well, let's have a look. First, it's a linear line, so we've got to work out its gradient. So what's its rise over run? This is a run of 1, 2, 3, 4. A rise of -1. So it's going to be y equals -1/4, or negative x on 4, I'm going to write it as, plus some constant. Now, we can logically say that it goes down by 1/4 each time we go across. So here it was at 3, so here it would have been at 3 1/4. So we would write it as y equals -x on 4 plus 3 1/4. And you could write it as 3 1/4 or 3.25, or however you want to write it, or as an improper fraction as well. So that would be 13 over 4. But whatever you write it as, it's basically, I would write it as 3 1/4, just because it makes it obvious what's going on there. Okay, so that's the equation. 2 points are located. Now just let's get a bit of extra space in here. 2 points are located at these 2 coordinates. Line L2 is perpendicular to line L1, so that's L1. So L1 has a gradient of -1 on 4. That's the only really thing that's going to be important. So line L2 is perpendicular to that. So what's the gradient of line L2? It's going to be y equals 4x plus some constant. We don't know what that constant is yet, but let's work that out soon. So it passes through the midpoint of A and B. So let's find out the midpoint of A and B. Now when we're finding out the midpoint, we just add together the x coordinates. -10 plus 6 is -4. We divide it by 2. And that gives us -2. That's halfway between -10 and 6. Then we do 5 plus 29 divided by 2. 5 plus 29 is 34. So that's going to be 17. So midpoint is -2, 17. And there are 2 ways we can think of this. One of the ways we could think of it would be just to intuit the answer. At -2, it goes forward 2 more, and if it goes forward 2 more, it's going to go up by 8. So I could add 8 to that. So I could say it's y equals 4x plus 25, because that's 5 more than that. But let's also do it if we were completely lost about what we were doing, because it's really easy to get yourself confused in an exam. Another way that we could do it is just by using our, where is it? So there's a very special formula on here, and that formula is, where is it? Equation of the line through P, point P with slope M. That is y take y1. I'm going to write this in green. Y take y1 equals m of x take x1. So that's going to be y take, and our y coordinate is 17. and our gradient is 4. It's x take, and it's take negative 2, so I'm actually just going to do plus 2. So that ends up being y equals 4x plus 8 plus 17, which is y equals 4x plus 25, as I worked out earlier. So that's one of the ways that we can do that one. So we can either do it just by using a bit of intuition. The x coordinate there is negative 2. If it goes up to 0, this is going to go up by 8, so we can add 8 to it. Or we can use our formula like we've got here if you just like to throw it in a formula, which I completely understand. Okay, so next up, expanding and simplifying. Now, we just want to be methodical about this. And so I'm just going to do this left to right. X times 2x is going to be 2x squared. X times negative 5, take 5x, plus 4x, take 10. Now negative 5x take 4x is going to simplify out to subtract x. And we still got to multiply that by x take 2. So 2x squared times x is going to be 2x to the power of 3. 2x squared times negative 2, that's going to be take 4x squared. So that's that one done. Negative x times x, that's going to be take x squared plus 2x, because negative x times negative 2 is positive 2. And it's going to be take 10x plus 20. Now we've got a few like terms in here. These are like terms. Fortunately, our like terms are sort of lined up with each other, which is a good little coincidence. So that's going to be 2x cubed minus 5x squared, take 8x plus 20. And that's all there is to it. This is quite a bit of work for 2 marks, and it is quite error prone as well. But just got to be careful, and feel free to come back and check this one later on if you've got a bit of spare time at the end. So now this one. This is our famous cubic solution, or cubic solving one. One solution to this equation is x equals 2. Determine all other solutions. This is a cubic. Doesn't look like it necessarily. We've got to rearrange it so that it is all on one side. And I'll do that in order. That's going to be x cubed, take 5x squared, take 12x plus 36 equals 0. We know that x equals 2. So that means that x minus 2 is going to be a factor. And the other side is going to be x squared plus bx plus c. We don't know what b is yet. We don't know what c is yet. That's what we've got to work out. We know that the term in front of here is going to be 1, because the only way we can get to x cubed out the front is to do x times x squared. And there's no 3 out the front of there. If there was a 3 out of front of there, there would also be a 3 in there. But there's not, so we don't need to worry about that. So let's try and work out what c is. C is always the easiest one to work out first. That's just going to involve this number. It's going to be negative 2 times c equals 36. So c is going to be just negative 18. Easy. Now let's work out b. Remember that there are 2 ways to get a so we're going to be looking at this one. This is always the easiest one to look at. We could also look at this one over here, but that one's going to be harder to solve, so I'm not going to do that. So there are 2 ways to get an x squared term out of this. One of the ways is to do negative 2 times our x squared in here. The other way to get it is to do x times bx. So that's going to be plus bx squared. And that's going to be negative 5x squared. All of these have got x squared in them, so we can take that out. Negative 2 plus b equals negative 5. B is quite straightforwardly negative 3. Oh, I can't really see that. Let's scroll down a little more. There we are. So b is going to be -3 there. So we know that what we end up with is x take 2, x squared take 3x take 18. So we want to think what two numbers multiply to -18 but add to -3. That will be -6 and 3. So that will factorize to x take 2, x take 6, x plus 3. Or to solve it, x equals 2, 6, or -3. So those are our three solutions for that. And if we really wanted to, we could try substituting them back into here. In the calculator free part, that's going to be pretty tough to do accurately. So just so long as and you'll always get integer answers for this, or no answer at all if it happens to not be something that can be square rooted. In this one, if you get completely lost on how to solve this, you can always use the quadratic formula again, as I detailed earlier on. So that's the quadratic formula down there. So if you get really stuck, just use the quadratic formula. That'll spit out your answers for you. But just remember to watch the sign of what we're looking for, because that'll give you the direct answer. So it'll give you the answers of 6 and -3, and not these numbers that go in here. But yeah, that's another way to do it. Okay, so that's that one there. That's factorizing our cubic. Next up, solving an equation. √3 tan x take 3 equals 0 for this range. What we always want to do in these situations is rearrange so we've got tan x on its own. And the way we can do that, √3 tan x equals 3, or tan x equals 3 on √3. We can rearrange that. This may not look like something that sort of makes sense. So what I'm going to do is I'm going to multiply by √3 on √3 just to sort of turn it into something that makes sense. That's 3 √3 over √3 times √3 is 3. These cancel out. We are left with just the square root of 3. Where is tan x equal to the square root of 3? That is the acute angle, x equals 60 degrees, or because we're in radians, remember that is 1/3 of a semicircle, which is at pi. So that's going to be pi on 3. So x equals pi on 3. But it could be positive or negative. It's from 0 to 2 pi, which is a full way around. Remember that tan is positive in these two sections. So it could be that one up there, or it could be that one down there. This is going to be pi plus pi on 3, which is 4 pi on 3, or 4/3 of pi. So x equals pi on 3, or 4 pi on 3. Those are our two answers for that one there. We just had to rearrange this, get rid of our square root on the bottom to realize that this was our exact value for 60 degrees, or for pi on 3. And then we had to make sure we got the second answer by thinking about where it was positive, because we have a range of 0 to 2 pi. A function has a period of k, and is defined by that. So what is k? So normally our function normal period of cosine is 2 pi, but we're helping it along. It's being multiplied by 2 in here. So k is actually just going to be pi. It's going to have a shorter period. It's going to go up and down more frequently than you might otherwise expect. And what's the amplitude? It's right there. It's 4. Easy enough. Remember that amplitude is always positive, never negative. So let's have a look here. We're doing from negative k through to k. It's cosine, so it's going to start at 4. We want to label that as negative pi, this as pi. What will we expect it to do? If that's the full period, we expect it to go the full range of its values. So we would expect it to look something like this. So it goes a full range of values. We don't need to have that one perfect, but we do need to have it end at the same point of 4 and go down to negative 4 as our minimum. And this should really, if you want to be completely accurate, this should be pi on 2. This should be pi on 4. It should be 3 pi on 4. Just a quarter, a half, and 3/4. And we should do the same thing on the other side. Again, it doesn't need to be perfect. Just know that when we talk about the period, if it's got a period of pi, that means that it will undergo its full range of values and get back to where we started when we get to pi. So even if you didn't get pi as that, no matter what answer you got up there, this should look exactly the same, this exact same graph, because we're going from negative of the period up to positive of the period. So we get a full range in there, a full range in there, even if I got the period completely wrong. There'd be a very good opportunity to get my follow-through marks there. And there's 4 marks to get. So it's basically just showing you understand what's going on. That's negative pi on 4, negative pi on 2, and negative 3 pi on 4. There we go. That's that one. Question 7, nearly done. The coordinates of the y-axis intercept of the line this. So we're looking for the y-axis intercept of this line. Now, we would rearrange this to 3x plus 5y equals 11. And one of the things about the y-axis intercept, the y-axis intercept occurs when x equals 0. So let's just throw x equals 0 in there. That is 5y equals 11. So y equals 11 over 5. Our coordinates will be 0 and 11 over 5. That one will be quite difficult to try and work out otherwise, if you didn't just realize, yep, the y-axis intercept occurs when x equals 0, and then we can just solve that. Straightforward though when we do. Okay. Next up, quadratic function is that. What are the coordinates of the y-axis intercept? Again, that occurs when x equals 0. So that's going to be negative 1 times 4, because these two cancel out. That is going to be negative 4, but remember they're asking for coordinates, so we've got to say 0, comma, negative 4. What are the coordinates of the zeros? Super ultra straightforward. That's going to be at 1, comma, 0. Remember that y is always 0. So that's the thing that makes this equal to 0. The one that makes this equal to 0 is going to be negative 4, comma, 0. There we go. 2 very easy marks. What's the equation of the axes of symmetry? Well, there's only going to be one axis of symmetry. I'm not sure why they wrote axes. But it's going to be halfway between these 2 points. So I'm going to do negative 4 plus 1 divided by 2. That's 3, negative 3 on 2. So that is x equals negative 3 on 2, or negative 1.5. Easy. 2 very easy marks there. There is not an axis of symmetry anywhere else. That is the only one. And the coordinates of the turning point, again, we've just worked out the x coordinates of the axis of symmetry. And if we, and by the way, this is an axis of symmetry over here. That is an equation. X equals negative 3 on 2. It is a vertical line that comes up here, and it will be sort of where the where this is symmetrical, and it will always be the turning point. So we want to subtract x equals negative 3 on 2 into there. So that is negative 3 on 2, subtract 1, negative 3 on 2, plus 4. What's negative 3 on 2 subtract 1? I'm going to call it negative 5 on 2, or negative, so this is basically negative 1.5. Take another 1 is negative 2.5. Then this one, plus 4, negative 1.5 plus 4 is going to be 2.5 as well, but positive 2.5. Feel free to convert these into decimals if it'll make it easier. Negative 1.5 plus 4 is going to be 2.5. And then it's going to be 2.5 times 2.5, or 2.5 times negative 2.5 rather. Or if we do it in fraction, we'd end up with negative 25 over 4. But this is why sometimes it's good to do it in fractions, because it makes it easier to work this out. But this would also be, I think it's 6.25. Just to throw it in the calculator. Let's give decimal. Yep, 6.25 there, which is 25. 25 times 25 is 625. So 2.5 times 2.5 is going to be 6.25 as well. So that's that one there. Now, is this the last one? Yes, it is. So let's just finish this one off, and then we're done for the calculator free section. So the graph of the relation y squared equals x, this relation will look like this. It is a parabola that is on the side. Hopefully you'll get one that actually goes through the 0 point there, like that. But that's a rough sketch of what it's going to look like. It is also, so it is our standard parabola that's been that's pointing sideways instead, or it is both half, or half of it would be the square root function. So what's going on here? It passes through the points 16a and b5. Determine the values of a and b. So if this goes 16 across, what's a going to be? And one thing that you should immediately see, there's going to be two values of a over here. X is 16, so when is y squared equal to 16? When y is equal to plus or minus 4. Pretty straightforward. So a equals plus or minus 4. And so the other one is when we've got 5, or negative 5 rather, down here. If that is negative 5 down there, so we got negative 5 all squared, that is going to be 25. So b is 25. So that's going to be further along this way, 25 over here. Makes sense. We would expect it to be further along than 16. And yeah, so that's that one. That's 3 pretty straightforward marks, just so long as you do some accurate substitution into these. Remember that this is our x value, this is our y value. You can just put them into the x and y value here, remembering that there are 2 potential solutions for our y value, for our y value, which makes sense if you do a quick little sketch of the graph before you get started. Okay, our other one. This is a relation defined by this here. Now this should be familiar as our circle. This x minus 1 all squared, y plus 2 all squared equals 4. It's going to be a circle centered on 1, negative 2 with a radius of 2, because this is, I'll just pull up the formula sheet, and this is one where the formula sheet is useful. The equation of a circle, right there, where is it? There we are. X take a all squared plus y take b all squared is r squared. AB is the center, r is the radius. So let's plot a few points before we actually get started. It's going to be centered on 1, negative 2, so this is going to be the center. It's got a radius of 2, so let's mark all the points 2 away from that. There we go. So all we have to do is just sketch a quick circle. It doesn't even need to be accurate. You just need to make it very plain that it has a radius of 2 and a center of 1, -2. And so that should really be 3 very easy marks right there. What feature of the graph indicates that a relation rather than a function is shown? And this is really just saying it does not pass the vertical line test. You can put in more details if you want, but it's pretty much understood. If you're talking about the vertical line test, you know what you're talking about. It's only worth 1 mark, so it does not pass the vertical line test, which basically means if I was to draw a vertical line here, it passes through the graph twice, which means there are 2 possible y values for a given x value here, which means it is not a function. So that's what we've got there. So that's the end of the calculator allowed part, or calculator free part rather. And obviously the notes do help you out, the notes that you're provided, formula sheet rather. So it's always good to refer back to that and just make sure you can understand what's going on. And it's good to practice these, make sure you know where to find the various things in the formula sheet itself. So yeah, fortunately the only thing we really need to know is most of this page that's got functions and graphs and trigonometric functions, and the top half of this one here on circular measure, radial measure, and trigonometric functions. That's all we'll really need to know for Unit 1, and we won't start to deal with these things until Unit 2. You might recognize some of this probability stuff as well. Okay, so I'll leave you guys to it, and hope that's been useful for you. I will get up the video for the calculator allowed sections very soon. Okay, have a great day. Bye.